on Friday we did 4.5 and we had started with some problems. We did a couple shorter proofs and then we went ahead and we listed out the given and what we're trying to prove for this problem. But we didn't actually set up or like do our proof yet. So statements, reasons, all right, so first thing is we're going to start with our given information. So L is midpoint of JN. PJ is congruent to QN. PL is congruent to QL. And then angle PKJ and angle QMN are right angles. So that was all given information. All right, so just kind of looking at the stuff, I think everything is marked here. L is the midpoint of JN. Obviously that's not like marked on here, but we'll look at that in a second. PJ is congruent to QN. Those are marked. PL is congruent to QL. Those are marked. And then angle PKJ is and QMN are right angles. Okay, so everything is marked in the picture just because, like I said, I like to visualize what's happening. So, just off of what we know out of our givens, is there anything else that I can say has to be true at the moment?
POK is congruent to PKJ because of the right angles.
What?
PKL.
Is what?
Is congruent to PJK or PKJ.
That, I mean, yes, that is a right angle, but that's not going to help me with anything.
JL is congruent to NL.
Why?
By definition of
Yep, so if we know this is a midpoint, then this has to split this in half. So then JL is congruent to NL, or however you want to write it. Definition of a midpoint. So now I know then, if that's true, ignore this line going down the middle. This piece down here is congruent, so I can now say that triangle, let me make sure I follow this right, JPL is congruent to triangle NQL by what? Side. So that's that these big triangles are congruent. I'm trying to prove that the little triangles here are congruent. But I know the big triangles are congruent. So now, what else then would have to be, or what angle could I say is true that deals with, or like what angles could I say are congruent in regards to things that I know because I now know this information? Because I know that all the sides are congruent. Obviously, I already know that the right angles are congruent. We've already dealt with that. But technically the right angle isn't in the big triangle, so never mind. But I'm trying to show that this triangle is congruent to this triangle, so what angles would help me with that?
Upper middle ones that are gonna give them.
Yes.
Maybe PKL and QML.
Not going to help me, not what I'm trying to find. I'm looking for a one-letter angle.
Q and P.
Nope. Well, I mean, they would be, yes, but
Is this like, is the 1 and 2 saying like those angles?
that's the angle. Yeah, the name of the angle. A lot of people ignored that and just gave me the, like, what the letters would be, but either's fine.
Okay, thank you.
I'm trying to prove that this triangle right here is congruent to this triangle right here. Angle Q is this whole thing, and angle P is this whole thing, so that's not going to help me. J and N. Angle J is congruent to angle N. Y. CPCTC. Corresponding parts. So that also means that, yes, P is congruent to Q. Obviously, L is congruent to L. But I don't need P and Q. That's not helping me because this is the whole big angle right there because that was the big triangle. All right, now, what other angle do I know is congruent?
K and M.
Which K? Which M? You can't just give me a one letter if it's got
Angle
multiple
K.
angles.
Angle.
Can't just give me one letter if it's got multiple things. I've got two angles here. Two angles are here.
Angle JKP and angle NQ.
Yep. Angle PKJ is congruent to angle QMN. Y. Not vertical angles. I'm up looking at the picture at the moment. And
No.
I know. I've got it so we can see the picture for the moment, and then I will go back down. Why are these angles congruent to each other? It's a theorem. Somebody get out your theorem postula book. Got minimal participation from y'all right now.
3.12.
What's the name? It's a named theorem. There is a named theorem that is the answer, not just a number. What are these two angles? Right angles.
Oh, right angle.
So how about right angle congruence theorem? So with all of that information, I have this angle, and this side are congruent. What does that mean?
Triangle PKJ congruent to triangle QMN.
Yep, triangle PKJ is congruent to triangle QMNY. Angle side. All right, our next proof is going to be much longer than this one. I've got somewhere between 10 and 11 steps on this one.
You said 11?
10 or 11, depending on
Say that again.
how we do it. 18. Given BD is perpendicular to AC, BD bisects AC, And we're trying to prove that angle ABD and angle BCD are complementary angles. All right, what's the first thing? Given. So BD is perpendicular to AC. I'm going to go ahead and put all mine together. BD bisects AC. So that's the given information. All right, just purely off of the information that they gave me, what else has to be true in regards to some angles?
Angle ADB is congruent to angle CDB by
Yep.
3.3.
Well, yes, but we can't say that yet. We need to say that they are right angles first. So angle ADB and angle CDB are right angles by the definition of perpendicular lines. Now we can say that they're congruent. So angle ADB is congruent to angle CDB by what?
Right angles congruence theorem.
Yep, right angle congruence theorem. All right, also based off of the given information, what do we know has to be true?
BD is congruent to
Yeah, not what I was looking for, but yes, that's true, and we will need that, so we'll go ahead and do that. BD is congruent to BD, why? Yep. You can just set it right there. All right, so what else do we know then? Something else using the given information.
AB is congruent to BC.
I do not know that.
AD is congruent to CD.
Yep.
By the definition of bisector.
Yep, I would specifically say segment bisector just because we also have angle bisectors, but yeah. So, by the definition of a segment bisector. So, as I'm going to go ahead and mark up some stuff here. So, I said AD is congruent to DC. I know that BD is congruent to itself. I'm just going to put little 2 lines there just to see it from my visual, but I just know that that's congruent. All right, so now what can I say?
Triangle ADB is congruent to triangle CDB.
Yep. By what?
Sine angle side.
Am I done?
No.
No. What am I trying to prove?
The angle ABB and angle BCD.
Yep. So a lot of times this is where our proofs have stopped. We've had to just prove that the triangles were congruent. So always make sure you pay attention to what they're asking for. And I say that because the other day when I was doing this, I was like, oh yeah, I'm done. And then I went, oh no, I'm not. Okay. So make sure you pay attention to that so that you don't like forget something. All right. So I know the two triangles are congruent. So I need to get some other information here to figure out what's going on. So I would say that then angle A is congruent to what?
C.
Yep. Angle A is congruent to angle C. Now, what you might do, just for reference here, ultimately I'm trying to prove that angle BCD and ABD are complementary. This is the same as this. Okay, so if you want to see it just up here for reference, I don't know why I just wrote a 3 there. Couldn't tell you what that was for. I'm just going to note here for myself that that's the same thing so that notationally as I go down, when I did this originally, I wrote BCD instead. But if it's just a single letter like that, just write C. But when we write our final answer showing that they're complementary, we're going to want to use this because we're trying to show exactly what it says. Yes.
In the proof, doesn't the be in the middle?
Huh?
The B have to be in the middle because it's an angle. But they have to be in the same group. Or am I wrong about that?
Up here or down here?
Not there.
No, it's whatever the angle is that we're looking at. So this is angle C. Whatever is in the middle is the, because it's like B, C, D. So it's this angle right here. All right, so if you want to do it this way, or if you want to go ahead and write it as BCD, either way is fine. So I've said that those are congruent. What allows me to say that those two things are congruent? Yep, CPCTC. Now, if I know these are congruent, what does that mean?
They're the same.
I'm trying to show that the angles are complementary, right? So that ultimately means I'm going to need to show something about the measures of the angles, right? What does it mean for something to be, for angles to be complementary?
Equal 90 degrees.
Yep, the measures equal 90 degrees. So I probably need to now take this, to throw back to like chapter 2, and say the measure of angle A is equal to the measure of angle C. Or if you're writing it as BCD, write that instead. What allows me to say that?
Definition of congruent angles.
Yep, definition of congruent angles. All right, this next one is maybe one that you wouldn't just recognize. So ultimately, I'm trying to show that these two angles are complementary, but I'm probably going to have to show something about some other ones first in order to show that. So I also know that this over here, right, is a right angle. It just had the one drawn for me on there. So if this is a right angle, then that means that my other two angles have to add up to equal 90 degrees, right? Because all of the angles inside of a triangle equal 180. So if this one is 90, this one and this one have to be equal to 90 when added together. So my next step that I'm going to go to is to say that the measure of angle A plus the measure of angle ABD, I'm going to go back up to the picture in a second, are equal to 90 degrees. Okay, so this angle and this angle, ABD, means I'm looking at this angle right here, are equal to 90. Okay, and that's because acute angles of right triangles are complementary. All right, so now I can take and I can replace A with C, or for still, if you're using this BCD, you can use that instead. So then my next thing would be that the measure of angle C, or I might write down here, measure of angle BCD, just so I can see it, plus the measure of angle ABD is equal to 90 degrees. What allows me to do that?
Substitution property.
Yep, substitution. So I was trying to show that ABD and BCD are complementary. I've got down here the measure of C plus the measure, or BCD, plus the measure of ABD equals 90. So then, based on that, what can I say?
Angle ABD is not congruent, and angle BCD are complementary angles.
Yep. And so in the final thing, even if you've just been writing angle C, because they used BCD up here, you need to write what they're wanting you to prove down here as well. And so they are complementary. What would be the reason for this? Yep, definition of complementary angles. Now, obviously, we haven't had any proofs that have been this long up to this point, right? Most likely you're not going to have one that is quite that long, but I wanted you to see it, and that's why we did that one. Because you could, obviously. Now, the ones I'm giving you aren't nearly as long. They're about half that size. But make sure you pay attention to what it's asking you for and use this to help you, because obviously this section is very proof heavy. Your next quiz is predominantly proofs, because that's what 4.5, 4.6, and 4.7 pretty much are. So use this to help you to start to go over that stuff, okay? So problems.
Is there any chapter with help proofs?
There are some that we won't do the proofs for, but there probably are proofs through the whole book.
So it's chapter 1.
At least through chapter 6 we'll have proofs, I know that.
Chapter 1 didn't have any.
So 9, 11, 15, 17, 23, 34, 35, and 36. 34, 35, and 36 are review, because we need to practice on that. But some of you seem to have thought that last time when I gave you some review problems, you just didn't have to do them. I'm making sure that you understand any problem that I tell you to do, like, you have to do it and turn it in, unless I say otherwise, okay? So these last 3 problems, even though they're review, they are getting turned in with this section, okay?